Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 3306. Count of substrings containing every vowel and k consonants 2. This problem is based out of the variable sliding window concept. Let's have a look on the problem statement. You are given a string, word and a non-negative integer k. These two values are given to us and we have to return the total number of substrings of word that contains every vowel at least once, should be greater than 0, and exactly k consonants. K is already given to us. This much is our problem statement. If I just have a look on the example, these two values are given to us, a word and an integer k. Integer k will be used to validate the substring, and from this word we have to figure out, or you can say capture the count of all the valid substring. So this is something given to us, and what we have to return is total number of valid substrings. Valid substrings. Substring, we totally understand that it's a piece, or you can say a contiguous set of characters. And for any substring to be a valid substring, it should have two conditions satisfied. First one is the substring will only contain k consonants. Not more than that, not less than that. So if I just maintain a count will be equal to k. Count of consonants should be equal to k. And the second condition is all the vowels should be present in the substring at least once. If all the vowels are present at least once, it means for all the vowels the frequency should be greater than 0. Every vowel frequency should be greater than 0 for second condition to be satisfied. So if these two conditions are satisfied, that substring will be a part of my answer, will contribute 1 to my answer, correct? And that integer we have to return. Okay, now the problem statement is clear to you. Let's try to understand how we can achieve this solution. See, first of all, they are concerned about all the valid substring, and substring you can consider like a piece. Let's say if this piece I'm considering, this is a substring, and this substring should be valid. And to make it valid, I have two conditions. First condition is k consonants should be there, and second condition is all the vowels should be present at least once. If I just try to have a look, vowels are A, E, I, O, U. Vowel A is present only once, E is present only once, I is present only once, O is present only once, U is present once. Okay, so second condition is satisfied. What about the first condition? K consonants. If I just have a look on the consonants, consonants are 1 in number. Consonants count is 1. So first condition is not satisfied, second condition is satisfied. Ultimately, both conditions are required. So this is not a valid window or valid substring. So this is not going to contribute to my answer. Now what should we do in this case? If this window is not satisfying, then try to expand the window until you are getting a valid window. So from this, we are getting an intuition that this is definitely a sliding window approach where we have to maintain a window which is a valid one. So to maintain a window, we require 2 pointers. Let's say I take a 1 pointer at this position. Let's also take second pointer at this position. Then keep expanding the second pointer until you find a valid window. In this case, it is not valid. If I just make J here, this is also not valid. If I make J here, this is also not valid. Why not valid? Because all the vowels are not present. If it is here, still not valid, not valid. And when it is here, A, E, I, O, U, vowels are present, but consonants are 1 in number. When I am coming here, at this position, the first condition is k consonants, and the consonants counts are 1, 2. Consonants counts are satisfied. What about vowels? Every vowel is present at least once. So this is my first valid window, starting from I equal to 0 to j equal to 6. This is a valid window, right? And now, whenever we encounter a valid window, what we do usually is answer plus plus. As we have reached the valid window, we will try to expand the window. See, this is a vowel, and even after including this in my sliding window, it will remain valid. Why? Because all the vowels are at least once and only k consonants are there. If I increment it again, still k consonants are there. If I increment it again, k consonants are there. If I try to increment it further, it will invalidate the first condition of a valid substring. Now, here, ending at these three positions, I will again get a valid window. So it is making sense that when we are incrementing the j, if I'm getting a vowel, I keep on incrementing it. Okay? But see, now at this position, it is a time to shrink the window. Shrink the window means incrementing ith pointer. If the ith pointer is coming at this position, it is again valid. If the ith pointer is coming here, it is still not valid. If the ith pointer is coming here, it is still not valid because f is there. If the I pointer is coming here, now it is valid. Means starting from 3 to 10, it is valid. Why? Because f and k is there and a, e, I, o, u is also there. Correct? So now the position is my I pointer is at I, index 3, and j pointer is at index 10, which is f. Okay. But in this case, are we missing on any valid substrings? Before I there is, if I start from index 1 till index 7, if I go from index 1 to index 7, it is E, F, I, O, U, K, A. It is a valid window, but we are unable to capture that, right? Why? Because the I pointer has passed it. So we were able to figure out valid substring ending at j, but we were not able to capture the valid sliding window ending at 7th index but starting at 1st index. Let's have a look on this again in detail. See, this is my window, and my first window started from this I, and it became a valid window A, E, I, O, U, and this j, because k is 2 consonants are there, k and f and k. Correct. So in this case, I am capturing that there is one valid window starting from index I equal to 0 and j equal to 6. Correct. But there are other windows as well. For j equal to, starting at I equal to 0, j equal to 7, I equal to 0, j equal to 8, I equal to 0, j equal to 9. But when I'm coming to j equal to f, at this position, we are able to capture all the windows starting from I equal to 0. But there is one window. There might be some windows which are missed, which are starting later I, but any of the j. Let's say j is now at position 10. If I consider j at this position and I at first position, this window is again valid. So this is showing us that we can't directly increment j, sorry. If I do not increment j, let's try the other way around. Instead of incrementing j, I will try to increment I. But now in this case, it is becoming invalid. To make it valid again, I will increment j. Right? And then I will increment j, and now it is valid. But see, starting from index 0, we were able to capture only one valid string. But in the previous example, we see that starting from index 0, there is more valid strings, like from 1 to E as well, 1 to I, 1 to A, and 1 to K. So starting from index 0, there are 4 valid substring, but we are able to capture only one in this case. So both of these approaches are not going to work. Why? Because this time we can't keep our window fixed because of the constraints that we only require 2 consonants. So we can't even keep our window size fixed, and we can't take the variable sliding window approach blindly just by checking the vowel frequency greater than 0. So now in this case, what we have to do is capture all the substrings, all the valid substrings starting from index 0, right? And what is causing the trouble is that elements after j which are vowels, right? Because if these vowels are included in this current window, it is going to make one more window. So starting from index I equal to 0 and j equal to 6, there is one window. From 0 to 7, there is one valid window. 0 to 8, there is one window. 0 to 9, there is one window. 0 to 10, there is not a window. So there are 4 valid windows. And why at 10 there is no window? Because 10 is a consonant. So from this, we can get an idea that starting from any index till any index, starting from index I to index j, if we are able to capture k consonants, right? And then k consonants are captured, but still we are able to expand the window because we are able to capture vowels. We can expand till we encounter the new consonant, because if k is already 2, when k will be becoming 3, it will cause a trouble. Valid window will become invalidated. So until it become 3, we can expand of the current window. So if at j, I just directly tell you that the next consonant is present at 10. Current j is 3 and the next consonant is present at 10. So 10 minus 6 are the values which are from j to less than 10. 6, 7, 8, 9. It signifies that, see, till j equal to 6, we have a valid window, and after j, the next consonant is present at index 10. So if it is present at index 10, from 10 to j, all the elements will participate in a valid window. So what we can do is, starting from index I, answer will be incremented by the next consonant of j minus j. So this is the formula we can use. So for every j, we just figure out the next consonant. Next consonant is present at index 10. In this way, we can capture, the answer will be captured starting from index A, it will be 4 in number. Now you have got the idea that what exactly we have to do to capture the answer. Now you can apply your standard template. What is the standard template for sliding window? First of all, include the current element. Current character in this case. Including current character. After including current character, it is your duty that you are making the window valid. Make window valid. Why we are making window valid? Because after making a window valid, we can capture the result. Capture answer. Capture answer, correct? So starting from index 0 to j equal to 6, I have a valid window. And now when I'm going to next position, j equal to, first of all, what I'm going to capture is 10 minus 6, which is the current number of valid substring we have. We can form starting from index 0. Okay, after that we are incrementing j. If we are incrementing j, I will check whether it is valid or not. J is incremented, and then I will try to make the window valid. And to make a window valid, we can apply this condition while the consonant count is greater than k. If the consonant count is greater than k, there is some space to reduce items from the left side, that is I++, and reducing value from the left. And we have to capture the answer. See, if consonant count is greater than k, it will automatically be equal to k, around equal to k. Or we also have to check the vowel count. The map is something like vowel frequency, A, E, I, O, U, and the count. Count is 0, 1, 2. If it is 0, remove the entry. So just by checking the size of the map, we can get to know whether it's a valid window or not. So while map dot size is equal to 5, because 5 vowels are there, and consonant count is equal to k, it means this is a valid window, and now you can capture it. And what you are going to capture is the next consonant of j minus position of j. This is something we are going to capture, and this is starting from index I, and you keep on capturing it I++, because there might be a vowel at position I. So do the I++ and capture that as well. So starting from, if I just do the I++ and then check, if it is still valid, then use the same formula. Next consonant of j minus j. Now in this case, there is one special thing that we are discussing. Position of the next consonant. Next consonant. Why I am just checking this next consonant from this array? Why? Because so that we don't have to spend order of n extra time while we are doing the code. For that you can easily do it. If I just mark the indices 0, 1, 2, 3, 4, 5, 6. Position of the next consonant I am going to capture. For 6 there is no next consonant. For you 6 is the next consonant. 6, 6, 6. And now for F is next consonant is 6 at 6th position. Now the next consonant position is updated to 2. So for E the next consonant is present at 2. For A the next consonant is present at 2. Order of n time we can do this kind of pre-processing. So one time order of n pre-processing is going to help us save order of n time while doing the coding. And during the code we can iterate over the string and we can find our answer in order of n time using sliding window. Just keep these 3 things in your mind, including whenever we are including a character. First of all, we have to make the window valid. Making a window valid by just ignoring the elements from the left if the consonant count is greater than k. If the consonant count is equal to k, then if the map size is equal to 5, we can capture all the strings starting from index I to index j and any other vowel. If the vowels are present, all the vowels after j. So the next consonant is this. Next consonant minus this j position will be the current count of valid substring. This is how we have to approach, and we will be doing it in order of n time and order of, there might be order of n space if we are doing that kind of pre-processing to store the next consonant. Now let's have a look on the code. To make the window valid, we want a frequency of every vowel to be greater than 0 and consonant count equal to k. So if these two conditions are satisfied, that is a valid window, and we are going to capture the answer. An answer we are going to capture on the basis of next consonant index. This is something we discuss in our approach. So next, consonant index we are going to capture for every consonant, otherwise it's length of the array. So now this is our window that we are going to process while right is less than word.length. Firstly, we are going to append one character. After appending one character, the window might get disturbed. And now the window we have to fix. To fix the window, while the consonant count is greater than k, keep removing element from the left side. And if we are removing something, so that removal will impact my consonant count and the map, so adjust accordingly. Now if we are at a valid window, there might be the condition that this is the consonant count we are checking, other one is vowel. Frequency map size is equal to 5, then it is valid, otherwise it is not valid. So as far as we are getting a valid window, we are capturing all the windows starting from left and then expand left till we are getting valid window. Keep capturing and expanding from left side. If we are getting invalid window, then just try to expand it and move to the next iteration. And this is the utility function that I have created just to check whether a character is vowel or not. I'm going to drop the code in the description below. You can have a look. I hope you have understood the approach. Thank you guys. Bye bye.